But we'll pick up kelvins later. Right? For now, I want to go on to how this change in temperature takes place, how this thermal energy transfer takes place. Who can give me one way that energy gets transferred? Touching. Touching, contact. What do we call heating or thermal energy transfer by contact?
Touch.
Conduction.
Excellent. Conduction. Conduction. Give me an example of conduction. Touching a hot stove. Yes, rubbing your hands together, there's actual contact there. Again, the source of the heat is both friction and the metabolic process of using your muscles. But then, if I then touch my nose, right, I rub my hands together and I touch my nose, then that will be heat transfer by conduction. As my warm hands heat up my cold nose. All right? So that's conduction is by contact. What else? What's another way for thermal energy transfer to take place?
Radiation.
Radiation. Radiation is, this is contact. Radiation is thermal energy by way of what? Light or other forms of
Energy.
wave energy. More specifically, electromagnetic waves. Electromagnetic.
Is that how a microwave works?
Yes. Electromagnetic waves. And the electromagnetic spectrum includes such waves as ultraviolet, what? Gamma rays, X-rays, microwaves, radio waves. No. Good guess, but electromagnetic radiation, right? All of those waves, by the way, and we'll get to this when we get to waves and light, all those waves move at the speed of light.
What about, radiation for cancer?
All right, so that's radiation. What's the most common example of radiation that you experience?
Sun.
Radiation heating, yeah, from the sun. We get radiated energy from the sun in the form of visible light as well as ultraviolet and infrared. Okay. Then the third way that energy transfer takes place, thermal energy transfer takes place, is close. I mean, good guess. Not close, but good guess. And you'll see later why it was a good guess. It's another similar word.
Contraction.
Good. Convection.
Oven. Like the oven.
Like the oven. Now, first of all, what is convection? And then we'll talk about how it applies to an oven. Convection is thermal energy transfer by way of a fluid. And next week we get to dive into fluids. Pun intended. But for now, a short definition will suffice. What is a short definition of a fluid?
Liquid.
Okay. An example is liquid. Another example is gas. But the definition would be a substance that can take the shape of its container, right? It has no definite shape. And that's why liquids and gases are fluids. They flow. So, does convection take place in just any old oven?
Yes.
Yes, you're right. It does. Why? Well, what's the fluid in an oven? Gas, right? The air. Okay. Where where's the heating source in a conventional oven? Okay, down at the bottom.
There's water.
And as you heat that air down at the bottom, what happens to it?
Rises.
It rises. Why? Because it's hot.
Because it wants to go to the colder rooms, since the hot things right there.
Okay, good guess, but no. Think about what we said a second ago. What happens to things as they get hotter? They expand. And if they expand, then the space between them is larger, while their mass remains the same, which means it's now what?
Not responsive.
Not as dense. So they're less dense now. Well, that cool air above it, relatively, is not as dense. The cool air above is how compared to the hot air below. It's denser, right? It's more dense. So, on whom does gravity pull harder?
The cold air.
The cold air, because it has a greater density, more mass per unit volume.
So gravity pulls on air.
Absolutely. Everything has mass. And air has mass. Yes. We'll have to do a demonstration to address that.
Yeah.
But-
Just
Well, yeah, the fan
You know what I mean?
pushes the air. Yeah. That mass. Now, so gravity pulls harder on the more massive object, and therefore causes that cold air or cooler air to sink. And as a result, it displaces the hot thing and makes the hot thing go up. So technically, it's not accurate to say heat rises or hot things rise. It's really better to say that the cold thing sinks and pushes the hot thing up. But it's all a frame of referencing, right? If you want to say heat rises, I'm fine with that because it's true. But some people get picky and say, well, no, technically, well, okay, fine, but just change frame of references. Frames of reference. Now, so let's apply that to a convection oven. A convection oven is different than a conventional oven. In how? What does it do? If we don't have a convection oven, if we sit in a conventional oven, what will happen over time? What will be up top? Yeah, a whole lot of hot air.
Oh, so it's
And what will be on bottom? Relatively cooler air, or at least in the middle, right? And so, what happens to your cookies on the top rack? They burn, while your cookies on the bottom rack, or middle rack, aren't done yet, okay? And so what is a forced convection oven?
All around, right? Not just the bottom.
Actually, they're lazier than that.
They have
They put in a fan. I put in a fan that will then move that fluid back down. It forces the fluid to flow all around, and so it improves even heating. And incidentally, yes, there is a heating element at the top of your oven too, but that's for broiling or whatever. But the difference between a conventional oven and a convection oven is a convection oven has forced convection. In other words, it pushes fluids around to make sure that